Right, today's topic is Algebra 2, which is on indices. Indices is a base raised to a power. So you got the base and the power. An example would be a base a to power n, where a is the base and n is the power. Remember, power is also called exponent, and it's also called index. So next thing to do is to learn the law of indices. So law of indices. Right, there are 7 laws of indices. So let's just put 7 laws of indices. The first most important one is number 1, anything to the power of 0. So base anything to the power of 0 is 1. So give an example. A to the power of 0 is 1. Or if I say e to the power of 0, that's 1. Or if I say 3 over 5 to the power of 0, that would be 1. So that's the first law. Law number 2 is anything to the power of 1 equals anything. So if I say a to the power of 1, that becomes a. 3 over 5 to the power of 1 equals 3 over 5. Law number 3. Multiplying same base. Multiplying same base. So a to the power of m times a to the power of n equals a m plus n. That's law number 3. So multiplying the same base. So give an example. X to the power of 3 times x to the power of 5 equals x to the power of 3 plus 5. Now becomes x to the power of 8. Another example would be t to the power of 2 times t to the power of minus 6 will be equal to t to the power of 2 plus minus 6, and that becomes t to the power of 2 minus 6, which is t to the power of minus 4. Rule number 4. Dividing same base. So if you have a to the power of m divided by a to the power of n will become a to the power of m minus n. So give an example. If you have x to the power of 5 divided by x to the power of 3, that becomes x to the power of 5 minus 3. That becomes x to the power of 2. If we have t to the power of 8 divided by t to the power of minus 2, that will become t to the power of 8 minus 2, and that becomes t to the power of 8 plus 2, which is t to the power of 10. Rule number 5, multiplying power indices. So if I have a to the power of m, or bracket to the power of n, that will become a m to the power of m times n, which becomes a to the power of mn. So give an example. A to the power of 3 to all to the power of 2 will become a to the power of 3 times 2, which is a to the power of 6. T to the power of 4 times a half will become t to the power of 4 times 1.5, which is t to the power of 4 over 2, which is 4 times 1 over 2, which is t to the power of 4 over 2, which equals t to the power of 2. Try another one. If you have t to the power of 3 over 2, all to the power of 1/3, that will become t to the power of 3 over 2 times 1/3, which is t to the power of 3 times 1 over 2 times 3, which equals t to the power of a half, because 3 cancels 3, and that gives you 1 over 2. Fraction power. Number 6. So a to the power 1 over m is written as root a m, m root a. Example will be a to the power of a half is 2 root a. 2 root is also written as root. This is a default because 2 is the first one, so it's the default. So when you say root 2, it's the same thing as root. So 4 to the power of a half is 2 root 4, which can also be written as just root 4 because root is 2 root as a default, and therefore that would be, actually it's plus or minus 2, but we just take the positive value, so that's 2. Another way of doing that is to say, well, so 4 to the power of a half is the same thing as 4 times 4. 2 times 2 is 4, so that's 2 squared to the power of a half. Using our multiplication power, that will be 2 to the power of 2 times a half, which is 2 to the power of 2 over 2, and that becomes 2 to the power of 1, which is 2. So that's another way of writing that. Let's do another example. Let's do 9 to the power of a half. We expect that to be 2 root 9, which is 3. To prove that it's 3, what we need to do is do the same thing, but change 9 in terms of 3. So 9 to the power of half is 3 squared is 9 to the power as it is. So I just replace 9 because 9 equals 3 times 3, which is 3 to the power of, that's 1 there, so 3 to the power of 2. So I've just replaced 9 with 3 to the power of 2. And then I multiply the powers. So 3, 2 times a half, which is 3, 2 times 1 over 2, which is 3, 2 over 2, which is 3, 2 over 2 is 1, and therefore that's 3. So that's the proof of root 9 is 3 using the indices. Let's try another example. (27) to the power of 1/3 is basically 3 root 27, and that becomes 3. But we can prove it if we want, because 27 equals 3 times 3 times 3, and that becomes 3 to the power of 3. So we can write 27 to the power 1/3 equals 3 to the power of 3, 1/3. And we now multiply the powers. 3 times 1 over 3, that becomes 3 over 3 in powers, and that is 3 to the power of 1, which equals 3. So that's the proof. Shall we try one more? 16 to the power of 4, 1 over 4. 16 to the power 1 over 4 is 4 root of 16, and that is 2. For us to prove it, we could just do, so what we need to do is we need to write 16 in terms of 2, that is 2 times 2 times 2 times 2, and that is 2 to the power of 4. So 16 to the power of a quarter is 2 to the power of 4 times a quarter will become 2 to the power of 4 over 4, which is 2 to the power of 1, which is 2. Fractional power of a(n) to over m. In this case, that will be, remember that a 1 over m of n to the power of n. But we know what a 1 over m is to the power of 1 over m, and that will become m root a all to the power of n. So that's what that is. In this case, n is not equal 1. N can be 1 or any number. But what we did last time was n equals 1. So when n is not equal 1, then we have a different situation. So let's try this. A to the power of 2 over 3 will be equal to, well, a to the power of 1/3 times 2. And we know what a to the power of 1/3 is. That'll be 3 root a, and then all to power of 2. So that's what that is. So the 2, or the n, is always the overall power in this case. Let's try another one. 4 to power, let's try 4 to power of 3 over 2. In this case, that would be 4 to power of a half, all to bracket to power, all brackets to power of 3, because 3 times a half is 3 over 2, and that becomes root 4 to all to power of 3, which is, now 2 root 4 is 2, so that'll be 2 to power of 3, and that becomes 8. Rule number 8. So that'll be a negative power. In this case, a to power of minus m can be written as 1 over a to power of m. So there's a relationship between negative and positive power. Another way is to remember this is, if I have 1 over a to power minus m, that will become a to power of m. Because 1 over a to power of m, because that's what a to power minus m is, 1 over a to power of m, and that will give you a to power of m. Just remember, 1 over 2 is 2, or 1 over 3 is 3. 1 over e equals e. Likewise, 1 over a to minus m to power minus m equals a to power minus m, or rather 1 over a to power of m equals a to power of m. That's the last of all the 8 laws of indices that we need to remember. So if I go straight to the top, it's actually 8, not 7. 8 law of indices that we need to remember. So that's 8 law of indices. 1, anything to power of 0 is 1. Number 2, anything to the power of 1 is anything. Multiplying same base. 3, 4, dividing same base. Number 5, multiplying powers. Number 6, fraction power. Number 7, fraction power still with 1 with non-1 in the numerator. Number 8, negative power, and that's all the examples on the law of indices. Right, first example on law 1. Try and do these, see if you can do them, and then pause, do it yourself, and then check the answer after you've done it. 1 to power of 0, well, anything to power of 0 is 1, so that's 1. 4 over 5 to power of 0 is anything to power of 0 is 1, so that's 1. 3.142 to power of 0, again, that's 1. Okay, example law 2, the second law, which says anything to the power of 1 is anything. Again, pause, write down the answer, see if you understand it, and then check the solutions afterwards. Right, x to the power of 1 equals x. 3x to the power of 1 is 3x. 8 over 3x to the power of 1 is 8 over 3x. Multiplying law, multiplying the same base, law number 3. So we know a to the power of m times a to the power of n equals a to the power of m plus n. So the same base now in this case, they have to be same base, otherwise it wouldn't work. So a to the power of 2 times a to the power of 3, and this is the exercise. I would like you to go through them, pause, do them, and once you are happy with the answers, check the solutions afterwards. Right. Okay, I'm hoping you've done them, and so you know what these solutions are. So let's see. A to the power of 2 times a to the power of 3, that will be a to the power of 2 plus 3, and that becomes a to the power of 5. So that's what that should be. Question number 2, x to the power of minus 3 times x to the power of 6, that will be x to the power of minus 3 plus 6, that will be x to the power of 3. Question 3, t to the power of a half times t to the power of a quarter, that will be t to the power of 1 over 2 plus 1 over 4. Keeping the power base denominator the same, so I get t to the power of 2 over 4 plus 1 over 4. So I've kept the first fraction same, denominator the same as the second fraction by multiplying top and bottom by 2. And that gives us t to the power of 3 over 4. Question 5. A plus b to the power of 2 times a plus b to the power of 5. Well, a plus b is the same as a plus b in the second factor. So, therefore, they have common base. Since we're multiplying them, we add the power. So that would be a plus b to the power of 2 plus 5. That becomes a plus b to the power of 7. And question number 5, in this case, y times y to the power of 3. Well, y is y to the power of 1, so that's y to the power of 1 times y to the power of 3. And that becomes, well, they have the same base, which is y. You're multiplying them, so you add the powers. Y is common base, add the power. So that'll be 1 plus 3, and that will be y to the power of 4. Now, question number 6. A b cubed times a squared b. Again, I can rewrite it as a to the power of 1, b to the power of 3, times a to the power of 2, b to the power of 1. Now, look at the like terms of same base. So I've got a to the power of 1 times a to the power of 2 times b to the power of 3 times b to the power of 1. So it's the same thing. So we're just bringing the like terms together. So in this case, I've now got a to the power of 3 times b to the power of 4. So that's what the answer would be, because I get a to 1 plus 2, b to 3 plus 1. So that's how I got my a to the power of 3 and b to the power of 4. Law number 4, dividing same base. Well, the law for that one is a to the power of m divided by a to the power of n will be equal to a to the power of m minus n. So here are some examples, 1, 2, 3. See if you can do them. Pause it and do them. And once you've done it, go back to the video and check the solutions. Right, so I'm hoping you've done them. Now that you're back, so we get r squared minus 6, and that becomes r to the power minus 4, which is, well, 1, because it's a negative power, 1 over r to the power of 4. So that will be the answer. Question number 2, x 3/4 divided by x. So that is x to the power 3 over 4 divided by x to the power of 1, which is x to 3 over 4 minus 1. So in this case, I want to keep the fraction with the same denominator. So that will be x to the power 3 over 4 minus 1 over 1, which is x to the power 3 over 4 minus 4 over 4. So multiply the right fraction by 4 at both numerator and denominator, and therefore that gives x to the power minus 1 over 4. And x to the power minus 1 over 4 is 1 over x to the power 1 over 4. Don't forget the negative power relationship to the positive power. Right, question number 3 is likewise similar actually. So let's do the same thing. X to the power of 3 y squared divided by x to the power of 1 y cubed. And now we're going to write x to the power of 3 x to the power of minus 1, because the bottom one will be negative, and y squared and y to minus 3. So what we now do is add the common base, has to be common base, same base. So that will be x to the power of 3 minus 1 and y to the power of 2 minus 3. And that gives x to the power of 2, y to the power of minus 1, which will become x squared times 1 over y to the power of 1, and that will become x squared over y. Multiplying power. So now this is with the powers, we just multiply the power in this case. So that's an example. A to the power of n into bracket to the power of m equals a n m, which means that it's a n times m. So I've got a few examples for us to do. Example number 1 will be x squared to the power 3. You need to see if you can do that. Example number 2 will be a plus b to the power of 3 into bracket 4. And example number 3 will be a b squared to the power of 4. Now have a go, see if you can do these questions, and then pause and then check the answer afterwards. Right, so hopefully you've done these questions and then you've checked the answers now. So now you're going to check the answer. X squared to the power of 3 is going to be x 2 times 3, which is x to the power of 6. A plus b to the power of 3 times 4 will be a plus b to power of 12. ab squared to the power of 4 is actually a to the power of 1, b squared to the power of 4, which means we have to multiply everything by 4 and the powers by 4, so that would be a to the power of 4, b to the power of 8. And that gives us a to the power of 4, b to the power of 8. Right, question number, law number 6. Fraction power, root as power. So there are two types of fraction power, really. One is root as power, where you have a to the power of 1 over m. That would be root as power. Example is a to the power 1 over m equals root m root a. Now, the second one is a to the power of n over m. That's root of a power. So that will be a to the power of n over m equals m root a, all powered by n. So an example of this to give you to do is to try question number 1 here, which is 4 to the power of a half, and 2 x to the power of 1/5, and number 3 125 to the power of 1/3. Number 4 is, let's stop at number 3 there. The next one here is, the other example for the second part is number 1. We should try 9 to the power 3 over 2. And number 2, we could try 16 to the power of 3 over 4. So those will be a very good example to do and see what we can get. Now, pause and have a go with these questions. See if you can do them. And then once you've done them, check the solutions. Right, I'm presuming you've done them, paused and done them, and then now you're checking the solutions. 4 to the power of a half is basically 2 of root 4, which will give us 2. This one will be 5 of root x, and that's just it. This one will give us 3 of root 125. I'm expecting that to be 5. If you're not sure, again, remember that 125 is 5 times 5 times 5, which is 5 to the power of 3. So you could have written 5 to the power of 3, all to bracket 1/3, and that could give you 3 over 3 when you multiply the powers, right? And that will become 5 to the power of 1, which is 5. So the second part here is when n is not 1. So n is 3 here in this case. It could be any number. So to write this out is going to be 2 root of 9, all to bracket power of 3. That will be 3 to the power of 3, which is 27. And likewise, 16 cubed to the power of 3 over 4. So that will be 4 of 16, or cube. And 4 of 16 is 2, or cube. And this is 8. Another way to do that is 16 is 2 to the power 4. So you could do 2 to the power 4 times 3 to the power 4 times 3 over 4, 3/4, and that will be 2 to the power of, well, you could do 12 over 4, which is 2 to the power of 3, and that is 8 as well. So that's another way you could do it. Law number 8 of indices, negative power. An example, so a to the power of minus m will be equal to 1 over a to the power of m. Just remember that the negative power in relationship to the positive power is an inverse or reciprocal. So I got some examples to go through. And the first example will be you should be able to do, say, question 1. Have a go with question by yourself. And then once you've done that, check the solution. So the question 1 will be x to the power minus 2. How are we going to write that? Number 2 will be x. Let's just use a number here in this case. 2 to the power minus 3. What would that give us? What about number 3, which is 1 over 27? How could we write that? Question number 4. If we have 1 over x plus 1 squared, how could we write that? What about question number 5? Let's just write this one. Question number 5, which says 1 over, to write the question. Number 5, 1 over x plus 3 to the power minus 4. How could we write that? Number 6, let's have b a to the power m. How could we write that? And finally, if we have 7, 3, 4 to minus 2, how could we write that one? So these are questions. Have a go with these questions. Once you are happy with it and you got your solution correctly, check the solutions from these examples. Right, I'm hoping you've done them and now you know your solutions. So let's just do them. Right, x to the power minus 2 is, using the formula above here, is actually 1 over x squared. And 2 to the power minus 3 is going to be 1 over 2 to the power of 3. And 2 to the power of 3 is 8. 2 times 2, which is 4, times 2 again, which is 8. So that will be 1 over 8. Now, 1 over 27, you could write this in, you could do this in two ways. You could say 27 to the power minus 1, and that's correct. But we need to simplify 27. 27, if you look up here to the right, 27 equals 3 times 3 times 3. That will be 3 to the power of 3, because that's power 1, power 1, power 1. Add the powers. Same base, add the power, that will be 3 to the power of 3. So you could replace that by saying 3 to the power of 3, or bracket to the power of minus 1. Right, you remember multiplying the powers now? So there's 2 powers here, you need to multiply them together. That'll be 3 times minus 1. So that'll be 3 to the power of minus 3. And that gives the answer. So 1 over 27 is 3 to the power of minus 3. Or you could have done it this way. 1 over 3 to the power of 3. Because 27 is 3 to the power of 3. And then applying the negative power relationship, you're going to get 3 to the power of minus 3. So much quicker that way. all you need to change is 27 to the power of 3, and then you get 3 to the power of minus 3. Right, so I'm hoping you do this question. Look at this question, see if you can do them, and then pause, do them, and then check the solutions from what I'm going to do. Right, I'm hoping you've tried them, and hopefully you got them, but I'm going to do these questions now. These are indices questions. So the first question, question number 1. 4 to the power x equals 3 cube root 16, basically. Now, the best solution to this question is we're meant to solve for x, making x the subject. So that's what that meant. Solve for x makes x the subject. So the best thing to do is basically to, because of the cube, I need to rewrite these in terms of the powers. So I'm going to do 4 to the power of x equals 16 to the power of 1/3. So that would be the best thing to do at first. But 16 can be written as 2 times 2 times 2 times 2. So that would be 2 to the power of 4. And I can also write 4 as 2 times 2. That would be 2 to the power of 2, because there's 1 here, 1, 1, 1 there. You add the powers. If the base is the same and you're multiplying them, you add the powers. So let's rewrite these things. And so we got 4 to be 2 to the power of 2. So replace 4 with 2 to the power of 2. Still has the power of x. And 16, 2 to the power of 4. Still has the power of 1/3. Now we need to multiply the powers, right? So multiply the powers. So that would be 2 to the power of 2x equals 2 to the power of 4 times 1/3 is 4/3. Because 4 times 1 is 4 divided by 3. Now the powers will be equal if the bases are equal. The bases are equal, hence the powers will be equal. So what you're going to get is 2x, which is that one over here, will be equal to 4/3 because the bases are the same and there's an equal sign between them. So in that case, 2x equals 4/3, and therefore we need to divide both sides by 2. So you're going to get 2. So you're going to get x equals 4/2 times 3. Because I'm dividing 4/3 by 2, so that'll be 4/2 times 3. And that will give it, well, 2 goes in 4, 2 goes here, 1, 2 goes in 4, 2. So you will get 2/3. So therefore, x will become 2/3. So that's solution 1 for question 1. Question 2 of these questions is 9 to the power of x equals 1/3. So 9 to the power of x equals 1/3. Again, I need to rewrite 1/3. So I write 9 to the power of x equals 3 to the power of minus 1. Remember, 1 to the power of am equals a to the power of minus m. Well, in this case, m is 1 and a is 3. So that's why you get that. So that's how to write that. But also 9 can be written as 3 times 3. That's 3 to the power of 1 times 3 to the power of 1. Same base, when you're multiplying them, you add the power. That would be 3 to the power of 2. So we can replace 9 with 3 to the power of 2. So 3 to the power of 2 to bracket x. The power of x is still there, 3 to the power of minus 1. Now, you need to multiply the power on the left, so that will be 3 to the power of 2x. 2 times x is 2x, equals 3 to the power of minus 1. Now, again, 3 same base equals, and there's an equal sign between them. Hence, because they're same base, the powers will be equal. Therefore, 2x will be equal to minus 1. So that power here will be equal to that power here if their bases are equal and there's an equal sign between them. So therefore, divide both sides by 2x equals minus 1 over 2. So it's minus a half. Question number 3 from these examples exercise. More problems. Question number 3 is 16 x to 16 to the power of x all to the power of squared equals a quarter. So that's what we've got here in this question number 3. So what we need to do again is to replace the fraction into indices. Remember 1 over a to the power of m equals a to the power minus m. And there's m is 4, a is 4, m is 1. There's a 1 there. So that will become 4 to the power minus 1. But the 16 itself can be written as 2 times 2 times 2 times 2. So that would be, well, that's 2 to the power of 1, 2 to the power of 1, 2 to the power of 1. Same base, multiply them. Common base is 2, so you write 2. Add the powers, so that's 2 to the power of 4, 16. So we need to replace 16 here, so that would be 2 to the power of 4. And there's still an x in the power, so you put 4x. Still the squared in the power as well. So don't forget to replace the, when you replace 16, not to forget the x. And therefore, you multiply the powers out now. So that would be 2 to the power of 4x times 2. So that would be 8x. And that would be equal to, now 4 is 2. 4 equals 2 times 2. That's 2 to the power of 1 times 2 to the power of 1. You're multiplying the same base, add the powers. So 2 to the power of 2. So you get 2 to the power of 2 to the power of minus 1. Again, you multiply the power on the right. So that'll be 2 times 2 to the power of minus times minus 1. That'll be 2 to the power of minus. So that's 2 to the power of minus 2. And here is 2 to the power of 8x. So that's 2 times minus 1 is minus 2. Now, again, equal base. There's an equal sign between them. Therefore, their powers will be equal. So 8x will be equal to minus 2. So 8x equals minus 2. Therefore, divide both sides by 8. So x equals minus 2 over 8. Well, 2 is, how many 2 goes in 8? 4. So that will be equal to minus 1 over 4. So x equals minus a quarter. Question 4. Question 4 is x to the power minus 3 equals minus 8. Again, in this case, we're looking for a way to write this out. So what I'm going to do is to write 1 over x cubed equals minus 8. So what I'm going to do is multiply both sides by x cubed and divide both sides by minus 8. So first multiply both sides by x cubed. So I'm going to get x cubed times 1 over x cubed equals minus 8 times x cubed. So I've multiplied both sides by x cubed. Well, the x cubed here will cancel the x cubed there. So I'm going to get 1 equals minus 8 x cubed. Now I need to divide both sides by minus 8. So I have 1 over minus 8 equals minus 8x cubed over minus 8. Well, minus 8 will cancel minus 8. So now I have 1 over minus 8 equals x cubed. Okay. So, but I could rewrite my 8, because 8 actually is 2 times 2 times 2, which is 2 to the power of 1 times 2 to the power of 1 times 2 to the power of 1 will give us 2 to the power of 3. So that's what 8 is. So I can replace that 8 with 2 to the power of 3. So I get 1 over, well, I'll put minus here because there's a minus there. 2 to the power of 3 equals x to the power of 3. What I need to do now is to turn the fraction into the proper indices in this case. So that will be minus 2 to the power of minus 3. Don't forget 1 over a to m equals a to minus m. So that's what I've done here. My m is 3 and my a is 2. So I've converted that from there to this one. So that's where I get there. And the minus still stay where it is. I'm not touching the minus. And that'll be equal to x to the power of 3. So what I can say is, this is quite clever actually, because I can rewrite this as minus 2 to minus 1, right, times 3 equals x to the power of 3. So can you see where I'm going? So I still have minus 2 to minus 1 there, and I've got a 3 there. So I've applied that rule that says a n to m equals a n m. So I went back the other way. So I went back in that direction. So I've got my am here. So I went back and I still left the minus, I didn't touch it here. So that'll become x to the power of 3. So you can see here that my x's are literally the same, except the minus on this side. So if I take the minus in, actually, it will still be all right, because I'll just get minus 2 to minus 1 cube will be equal to x cube. Now, because the power are the same, all the powers are the same, the base will be the same. If the power are the same, the base will be the same. So in this case, since the power is the same as 3 and 3, the base will be the same, just as we apply power so therefore x will be equal to minus 2 to the power minus 1. So that's because the 3 and 3 are the same, and there's an equal sign between them. So therefore, the bases will be the same. So in this case, I get x to be equal to minus 1 over 2 to the power of 1, which is minus a half. So x equals minus a half. So that was a tricky one. The trickiness is between here and there. That's the trickiness. That's tricky. So you just have to watch out for those tricky situations. Question 5. Okay, so this one looks kind of interesting. Yeah, it looks difficult, but it's not. All you need to do is change the roots into fraction power, and then change the 1 over the fraction into indices. And that's what you need to do. So we know that the first rule is that a root, sorry, just take that. So m root a is 1. It's a to power 1 over m. So we've got that situation here. We also have the situation here, which is 1 over 25, which can be changed to 1 over 5 times 5, which is 1 over 5 squared. And that can become 5 to the power minus 2. applying that rule that says 1 over a to m equals a to minus m, where a is 5 and m is 2. So that's what we're going to do here, and that's what we need to apply. So the first one is the root 5 will become 5 to power a half. And then we times that by 5 to the power of x, and that will become 1 over 5 squared, because 25 is 1 over 5 squared. 25 is 5 squared. So if you have the same base, what do you do to the power when you're multiplying them? You add the power. So you get 5 is a common factor here for a base, and then x plus a half. So you add the power, and that will be equal to 5 to the power minus 2. Now you can see the base are the same. There's an equal sign between them. Hence, the powers will be equal. So therefore, x plus a half will be equal to minus 2. So that will be equal to that, because the base are the same and there's an equal sign between them. So that's what you need to watch out for when you're solving this kind of situation. And therefore, you're going to get, so all you need to do is take the a half to the other side, or take away a half from both sides. So you're going to get x equals minus 2 minus a half. X equals minus 2 and a half. That's what I meant. And now, if you turn into, this is mixed fraction, I need to turn into improper fraction, obviously. So that'll be 2 times 2. 2 times 2 is 4, plus 1, that's 5. So that'll become minus, there's a minus there already, minus 5 over 2. So that's 2 times 2, 2 times 2, plus 1, become 5. And that's why you get minus 5 over 2, the 2 of the fraction. And so therefore, x equals minus 5 over 2. Right, the final question from this more problem is question number 6. So if I zoom up here and look at question number 6 again. Question number 6 is root of 100 to the power of x equals 0.001. So now let's solve that problem. Again, it's all the things we already know, so we're just going to apply that. But there are some trickiness here. First of all, the trickiness is 0.01. 0.01 is actually 1 over 1,000. You can see, and therefore that will become 1 over 10 to the power of 3, because 1,000 is 10 times 10 times 10. So same power, but the same base, add the power, 10 to the power of 1 times 10 to the power of 1 is 100, times 10 to the power of 1 is 1,000, so that will be 10 to the power of 3. So 1 over 10 to the power of 3 is what we got, and then we turn it into our indices, because it's a fraction, I'll turn it into our indices, so that will be 10 to the power minus 3. Okay, so that one is already 10 to the power of minus 3. And we know what to do with the square root, turn into power fraction, because it's a root. So now let's solve the question. So 100, so root 100 to the power of x, be careful, it's not 100x, it's 100 to the power of x equals 0.001. So that will become 100 to the power of x, or to the power of a half, equals 10 to the power of minus 3. Now we need to multiply the powers in this situation. So that will be 100 to the power of x over 2. So that's basically multiplying the, just write that clearly. So that's x over 2. So that's the power of x times a half is x over 2. And that become 10 to the power of minus 3. But I can write 100 in terms of power of tens as well. So that will be 10 10 times 10, 10 to the power of 1 times 10 to the power of 1. That will be 10 to the power of 2. Good. So that's 10 to the power of 2. We can replace 100 with 10 to the power of 2. So that will be 10 squared times x times power of x over 2 equals 10 to the power of minus 3. So again, we need to do another multiplication of powers. So we've got 2 times x over 2. That becomes 2x over 2. And the 2 will cancel each other, you get x. So that we get here is 10 of 2x over 2. Better write this clearly because the power is important to write them clearly. So 2x over 2, that's the power, equals 10 to the power of minus 3. 10 to minus 3 is different from 10 to the power of minus 3. Be careful how you write your powers. It mustn't be on the same level as the base. Otherwise, you'll be marked down because it's confusing. You myself get confused as well. So now 2 cancels, or 2 over 2, you get x, so that'll be 10 to the power of x equals 10 to the power of minus 3. Now you can guess what x is. X equals minus 3. And that's the final question. Thank you.